Okay. Recalling, rational expressions are fractions with variables. Okay. So we're going to try to figure out how to simplify fractions with variables over the next couple days. Our strategy is going to be very similar to simplifying just fractions without variables. But we're going to make sure that I want to make sure that we're on the same page. If you can factor, then life is going to be a breeze for the rest of this chapter. If you're someone that struggles with factoring, you're going to want to get some extra help with that, because the factoring part is really the key to the whole thing. So in that respect, let's review factoring real quick. Most of us use the box and diamond factoring method. I'm going to go quick to both save time, and it should be a review. So if I ask you to factor this trinomial, is there anything in common amongst all the terms? No. So then I make a little diamond. I multiply the first and last terms together. Put it on top. I take the middle term and I put that down below. Then I say self, is there anything, what numbers multiply to 15, add to 8? Okay. So then I take the first term and goes in the first box. Last term goes in the last box. Answers go in here. Somehow, it doesn't matter how.
It's the only math that I actually like to do. Me too.
And then I find what's in common.
I don't know what about it, but it's fun to draw X's and little boxes. I don't know why.
So this trinomial that has three separate terms that are added together can be rewritten as two factors that are multiplied together in this way. The key here is that these groups are multiplied together. We're going to see why that's so important going on later. You can do number 2 on your own if you'd like. There's some more practice factoring. I don't want to spend time on this review right now. We have two big concepts here. The simplest form of a rational expression. The simplest form of a rational expression will be the expression written so there are no common factors between the numerator and denominator. Common factors being groups that are multiplied that are identical. And I'll show you we'll talk about how to actually simplify these in just a little bit. But our goal is to make sure there's nothing in common on top and bottom. We're going to actually start our focus on finding what are called excluded values. Excluded values are values
that are excluded.
Values of the given variable that make the denominator equal to 0. What's so bad about these excluded values? Why don't we want the denominator equal to 0?
You just don't want it.
We just don't want it.
What was the question?
What's important about these? Why are these values excluded? Why aren't we allowing these values that make the denominator equal to 0?
Because it doesn't work.
Because then we'd be dividing by 0. What happens when you divide by 0?
Error.
Your calculator says error. Your old calculators, like the TI, I think they're like 78s. They're like the previous version. There was a manufacturing error in them, and when you divide it by 0, they start sparking and they burst into flames.
Really?
Yeah. So that's why they have the TI-83s now. It just says error now. They fixed the problem.
Oh,
That's so fun.
that'd be so freaking cool.
Mathematically, you get inconsistencies. So getting denominators equal to 0 is bad
You
news.
do like your math homework. Oh, not gonna happen. Like heads on fire. Sucks.
So regardless, we don't want the denominator equal to 0.
Wait, don't they download No.
They're gonna blow up the world.
If I ask you to simply find the excluded values, I'm looking for values that make the denominator equal to 0. So all I need to do is take the denominator and set it equal to 0 and solve for the variable. What value of x makes the denominator 0 here? What value of x makes the denominator 0?
That's it?
Your excluded value here, EV, is equal to 0, is x is 0.
That one's gonna be negative.
I still don't get
Wait,
it.
do it again. I don't get it. Wait.
Excluded values are values of our variable that make the denominator equal to 0. So when I want to find the excluded values of a rational expression, I look at the denominator and I say, what makes that denominator equal to 0?
X equals 3.
So you can do that by just solving the little two-step equation here. You can guess and check here, and you should get 3.
What? Bam. Oh.
The excluded value is 3.
What about 7?
What about the 7 on top? Can the numerator, the top, ever make the bottom 0?
Wait.
No. Jack asked, what about that 7 on top? And my answer is, the 7 will never make the bottom 0.
You can put
Oh.
any number.
Anything on top will never make the bottom 0. So if what you're trying to do is find the excluded value, all you're looking at is the denominator. No matter how crazy and complex the top is, the numerator, we don't care. All you care about is the denominator. So in this case, now a little more complex denominator. X squared minus 16. So excluded value or values will be when x squared minus 16 is 0. So x squared is 16.
Should you come up with 2 answers?
You should certainly have 2 answers because you're solving a quadratic. What else could x be?
Negative.
Negative 4 are the excluded values. Okay. This in and of itself is not simplifying the rational here. What this is simply doing is saying what x's are you not allowed to plug in. They're excluded values. How about the last one? What we try to do for the last one? Okay, I want to find the value of x that make the last term equal to 0. You could. There's a lot of ways you could try this. What I wouldn't recommend doing is just subtracting like 4x and subtracting 5, and using a square root because you still have an x. From last chapter, from the last unit we did, chapter 10, we should have seen that you can either try to complete the square here, you can try to use the quadratic formula, or maybe my favorite method would be try to factor this. So let's see. If you use the box of diamond, you have to find 5x squared, 4x. What are some numbers that multiply to 5, but multiply to 5, but add up to 4?
5
Negative.
-1.
Would it be -5 or -1?
-5 and -1 unfortunately add up to -6.
Okay. Hey, I didn't.
Positive 5.
It's a good try because you know it's got to be a negative. You'd think it's got to be negative.
Positive 5x, negative
I got 5x.
Positive 5 and -1 add to 4, but they multiply to -5.
Yeah, it's
Copper.
This diamond problem is not solvable because there's no two numbers.
So what do you write on that? Rage quit?
No.
So there are no,
I wrote that.
in this case, well, more technically this would be no real excluded values. You'll see when you get to algebra 2, when you start talking about how you find the square root of, you can actually intelligently talk about the square root of negative numbers, but they form what's called complex numbers, not real numbers. So we'll leave those for years to come. Okay, let's start simplifying. I'm going to get as far as I can and then get the homework up for you guys. I'll just get the first one. That's where I got last time. Simplifying rational expressions if possible. Note the directions here. If you haven't already, read them on your own. They ask you to do two things. 1, simplify the rational expression if possible. 2, state the excluded values. We can already do part 2. In fact, let's do that real quick. What are the excluded values of our first example here?
0.
We'd say 3x equals 0. The excluded value is x equals 0. We can already do that without doing anything else. Okay. To simplify, what we want to do is, I always start by rewriting this equation that shows very, very broadly or very clearly what's being multiplied. So I'll do something as dumb as this. 2 times x, 3 times x. It might seem like a waste of time, but clearly showing what's being multiplied is pretty important. Is there anything in common on top and bottom? Are there any factors in common? Jack's found one. What factor is in common? The x. It's a factor because it's multiplied to everything. And it's the same. What's anything divided by itself?
0.
Not 0.
One.
Not itself. 1. What's 2 divided by 2?
0.6666.
1.
What?
2 divided by 2.
Oh, you said 2. I thought you said 2 divided by 3.
4 divided by 4? 1.
1.
X divided by x should therefore be 1. So these two cancel each other out, or they divide to 1. What's left over? 2 divided by 3. Is there anything in common between a 2 and a 3?
No.
So here's our simplified expression.
Change it to decimal.
Do not change it to a decimal. Leave it as a rational expression.
Don't do anything about it.
Leave it as a rational expression, which is just 2/3. Okay. This second one, let's see, 6 times x. This is 6 times x plus 5. What's in common here? What factors are in common?
6.
The 6's. So what's left over is an x and an x plus 5. There's no factors in common here because there's not an x multiplied to everything on the bottom.
You really need to parentheses there?
You don't need to put the parentheses. You could just write this x over. Okay. We'll finish these notes tomorrow. Here is the homework you can get started on. Do what